It's currently 1 a.m. and I do actually want to go to sleep. I have been sleeping so badly for the past few nights. I want to go to bed, but my brother decided that this would be a great time to go out and play basketball until like I don't know, God knows what time. So I literally like if I go to sleep now, he's going to be stranded and homeless and I have no to sleep. So I just have to wait for him to get back. So in the meantime, I'm going to do something which I've been meaning to do for a very long time, which is finally read the C++ core guidelines. Now these are written by Bjarne Strostrup and Herb Sutter, two goats, absolute legends. Obviously, well, not even obvious, but for those who don't know, Bjarne is literally the creator of C++, and Herb is a major player in C++ development as well. He's written a few proposals that I've read, and is just generally quite active. I think Herb is part of the C++ committee. I don't like. I don't like. I'm not familiar with like all the politics of the thing, but this is Bjarne's thing, and then you have Sutter. Yeah, like he's designed a lot of the features for the C++ language, as well as a library. Okay, he was on the ISO standards committee from 2002 to 2025, so he's actually stopped as of last year. But he is still chair of the Standards C++ Foundation. Okay, so he's not in the committee anymore, but he was for a long time. But he is still part of the foundation as like in the chair, I guess, which is like still the ISO, I guess. And it's also part of the chair of CPPCon. Yeah. So basically, Hubside is also really cool. But like, that's I don't know him because he's like the C++ community, or whatever. Like I know him because he wrote like something on reflection, or was it pattern matching, even, or both. And it's generally like done like interviews and stuff. So yeah, two very cool people who do a lot of interviews, and they've literally banded together to write these. Now I don't know if this. I assume this is last updated here. I don't know if this was written firstly here. I guess I'll find out. It says living document, right? But I don't know when it was initially made. I'm gonna assume this is a start date, because this says 2 months ago was the last commit. So that's crazy that's been this recent. It is fairly long, but I think it'll be very interesting, and yeah, I want to see what thoughts come up really as I read this. Yeah, it seems like a lot of it is coming from well, no, never mind. I'm filtering as him. What? Why am I here? I have no commits in this. Am I following? Hold on. I am definitely following Bjarne. No. I'm not following Herb. Now I am. Oh yeah, he's also working on oh, that's right. He's working on CBP front as well, which is also extremely cool. It's like a new, and like a new C++ kind of. If C++ could abandon its old baggage, that's kind of what CBP front is, which I think is pretty cool. Look at that. Main equals standard cout hello world. Holy standard couts. But this is interesting already. It's like a signing. It wants to evolve C++ itself. Yeah, I'll definitely have like a closer look into CBP front in the future, so I will bookmark it for now. I've known about it for a while. It's just like it just keeps escaping me. But anyway, I think this is a good starting point. So let me. My camera's like really not in a good position here, but we will. So this is a living document under continuous improvement. Had it been an open source project, this would have been released 0.8. Sorry, this would have been released 0.8. Copying, use, modification, and creation, blah blah blah. MIT, and you can contribute. I wonder how contribution works, because like they are guidelines. But okay, so suggestions for improvements. Okay, cool. I like that. Like it's open to different people, well, to anyone really. I mean, not to edit, but like to make suggestions. The sets of rules have not been clearly checked for completeness, consistency, and enforceability. Dribble question marks. Mark known missing information. Update reference sections. Many pre-C++ 11 sources are too old. For more or less up-to-date to-do lists, see unclassified protocols. Okay, cool. So like, we got actual like issues. You can read an explanation of the scope and structure of this guide, or just jump straight in. So this is just like a table of contents, right? I assume this will take me to the abstract. Yeah, okay, that's fine then. I'll just scroll down. So you got introduction, philosophy, interfaces, functions, classes and class hierarchies. Very interesting. Enums, resource management, also very a key one there. Expressions and statements, performance, very important. Currency parallelism, something I haven't really done. I keep forgetting rather to do this. I should really be using concurrency in my projects more, for like my XF bin stuff, for instance. Error handling, hugely important. Constants immutability, fairly straightforward, but still important. Templates generic programming, quite interesting, especially because templates language, like the template language for C++ is Turing complete. It's very flexible, but it can also be quite dangerous if misused, like dangerously bad for code. C-style programming is interesting. Source files and the standard library. And then you get some other stuff here. Modernizing code sounds interesting. Naming and layout suggestions too are also quite interesting. Profiles. My top bookmark here is why safety profiles failed. I do want to read that because I forget what that's about. And then specific things here, I can skip those. Okay. Right, abstract. Now you have to forgive me. I'm quite congested, which means my pronunciation is going to be a bit whack, but I'm going to try my best. This document is a set of guidelines for using C++ well. The aim of this document is to help people to use modern C++ effectively. By modern C++, we mean effective use of the ISO, currently C++ 20, but almost all of our recommendations also apply to 17, 14, 11. Currently 20. Like, right now it's on 26, isn't it? In other words, what you would like your code to look like in 5 years' time, given that you can start now. In 10 years' time. Sorry, what would you like your code to look like in 5 years' time? In 10 years' time? The guidelines are focused on relatively high-level issues such as interfaces, resource management. Yeah, we saw that. Such rules affect application, architecture, and library design. Following the rules will lead to code that is statically type-safe, has no resource leaks, and catches many more programming logic errors than is common in common in code today. And it will run fast. You can afford to do things right. Cool. We are less concerned with low-level issues, such as naming conventions and indentation styles. Interesting how that's called low-level. However, no topic that can help a programmer is out of bounds. So our initial set of rules emphasizes safety and simplicity. They may very well be too strict. We expect to have to introduce more exceptions to better accommodate real-world needs. We also need more rules. You'll find some of the rules contrary to your expectations or even contrary to your experience. Hold on. Before I read any further, I could have sworn there was another version of this somewhere that isn't on GitHub. Yeah, here. Literally on the ISO website. 2015. Okay. Holy moly. So these are so these are definitely quite old. It's these ones that have been updated since. But interestingly, it hasn't really been updated that much. Okay, so to be fair, back here it said, and soon C++ 17. Now it says C++ 20 here. So definitely need some catching up to do, but cool. Many of the rules are designed to be supported by an analysis tool, like ClangTidy, I guess. Violations of rules will be flagged with references to the relevant rule. We do not expect you to memorize all the rules. One way of thinking about these guidelines is as a specification for tools that happens to be readable by humans. Interesting. The rules are meant for gradual introduction to a code base. We plan to build tools for that and help others will too. Okay, so like linters and stuff, right? And I guess, yeah, I guess like analysis tools, right? Analysis tools. Comments and suggestions are most welcome. Awesome. So, introduction. So, it's currently supposed to be 2017. This is definitely outdated, right? Because it's on like 26 now. And 23. soon to be 29, taking likely future enhancements and ISO technical specifications into account. The aim is to help programmers to write simpler, more efficient, more maintainable code. Always good. So, target readership. This is in like the introduction, okay. So, all C++ programmers, including those who might consider C. Okay. The purpose of this document is to help developers adopt modern C++ and to achieve a more uniform code bases. We do not suffer the delusion that every one of these rules can be effectively applied to every code base. They follow the zero overhead principle. What you don't use, you don't pay for. Or if when using abstraction, you get as good performance, at least as good performance as if you were to hand code it yourself. Yeah. Okay. I've heard all these before. Don't panic. These guidelines are designed according to the subset of superset principle. They do not simply define a subset of C++ to be used. Instead, they strongly recommend the use of a few simple extensions that make the use of the most error-prone features of C++ redundant. So that they can be banned in our set of rules. Well, I don't know what that is. The rules emphasize static type safety and resource safety. For that reason, they emphasize possibilities for range checking, for avoiding different signal pointer, dialing pointers, and the systematic use of exceptions. Interesting. So it does use exceptions, which is interesting. But like standard expected was only added in C++ 23, I think. So this is definitely would be outdated. So I do wonder if that will change, especially with like pattern matching and like other features coming. Many rules are prescriptive, so rather than like don't do that kind of rules, they actually offer alternatives. Okay. These guidelines address the core of C++ and its use. We expect that most large organizations, blah blah blah, will need further rules, possibly further restrictions, and further library of support. Yeah, I think like NASA C++ is quite restricted. They restrict what you can and cannot use, just like for the sake of being safe. There are non-names too, okay. They are not intended to be minimal or orthogonal. General rules can be simple but unenforceable. Also, it is often hard to understand the implications of a general rule. More specialized rules are often easier to understand and to enforce, but without general rules, there would just be a long list of special cases. Okay. They are not meant to be read serially like a book. Sick. Well, that is what I'm doing for now. You can browse through them if you're using the links. However, their main intended use is to be targets for tools. Right. This is not a tutorial for C++, not a guide on how to convert old C++ code to more modern code. Really? It's supposed to articulate ideas for new code. Right, so it's just about refactoring then. Because it isn't feasible to convert a large code base. It's why like when I do that, I just rewrite it, and it's why I've rewritten certain projects of mine so many times. To good effect. They are not intended to force you to write in an impoverished subset of C++. They are emphatically not meant to define a Java-like subset of C++. Right, okay. The rules are not value neutral. They are meant to make code simpler and more correct than most existing code, without loss of performance. Yeah. They are not precise to the point where a person can follow them without thinking. We'd rather leave a rule or definition a bit vague and open to interpretation than specify something precisely and wrong. Sometimes precision comes only with time and experience. Design is not yet a form of math. That's interesting. Being intentionally vague so that you may clarify it later when you have a better idea of what you actually want to say. That is an interesting thing that's needed. The rules are not perfect. A rule can do harm. Let me actually highlight that. Sick. Seems to be frozen. Yo, can I get like a comment, please? Maybe it is an effective strategy to first be vague in your words and only clarify once you yourself actually have a better understanding of what you're trying to convey. Because sometimes you get an idea that you kind of can wrap your head around, but need to process more deeply. Probably, in this case, with more time and experience, as it says. The rules are not perfect. A rule can do harm by prohibiting something that is useful in a given situation. Okay. Instead, our aim is less ambitious. Do the most good for most programmers. If you cannot live with a rule, object it, ignore it, but don't water it down until it becomes meaningless. And suggest an improvement. Cool. Enforcement. This unmanageable. We want lots of rules. People don't like to read lots of rules, and they can't remember many rules. It's true. Which is where the compiler comes in handy. Actually, yeah, I think Bjarne was saying he wants to kind of like help compiler defaults, so like make compiler defaults reflect a lot of what is listed in these guidelines, so that people don't have to think about the rules. The compiler just tells them by default, and if they want to violate them, they can optionally, but like by default, have more useful compilers, more strict compilers. By default, again. We want guidelines that help a lot of people, make core more uniform, and strongly encourage people to modernize their code. Okay. Okay. I kind of skim through these, because it's just like introductory stuff. Although, the name of groups of related rules are called profiles. So type profile, bounds, lifetime stuff. The profiles are intended to be used by tools, but also serve as an aid to the human reader. We do not limit our comment in the enforcement sections to things you know how to enforce, okay? Like this, okay. So, let me just quickly take a peek at this. Is this talking about this? circlelang.org, 2024, Sean Baxter. Oh. Why did I think that this is written by Bjarne? It's not. But it is C++. Wait, no, it says reply to Sean Baxter. So who wrote it? I'm very confused right now. Oh well. Structure of the document. See the rule, reference number, like C.7. There are gaps. Yeah, yeah. There are reasons and rationales for why rules exist. I think that's very important. As like a general rule of life. People have a much easier and less resistant time. Much easier time with and are less resistant to following rules when they understand why they exist in the first place. Yeah, it's not rocket science, but it needs to be said. Because rules are hard to understand in the abstract, can be positive or negative. Right, okay, good. Examples, very good. Alternatives for don't do this rules, nice. Exceptions to the rules, enforcement, ideas how they can do it, okay. Some rules are hard to check mechanically. Okay. Examples are not intended to be used To be production quality or to cover all tutorial dimensions. Yeah, makes sense. We try to ensure that good examples follow the core guidelines, of course. Comes often illustrating rules where they be necessary. Okay. We use plain vector rather than the standard vector. Okay, sure. It is not language manual. This is to be helpful, I think, complete. Okay. Then we got major sections. So table of contents, I guess. Here we go, starting. So philosophy. Nice. Nice. Okay, I like what I see. So philosophical rules are generally not mechanically checkable. However, individual rules reflecting these philosophical themes are without a philosophical... Bro, I can't read English? They are generally not mechanically checkable. However, individual rules reflecting these philosophical themes are. Without a philosophical basis, the more concrete, specific, or checkable rules lack rationale. Right. So this is like why we do what we do, you know? Express ideas directly in code. Don't do comments, just put them straight in. I mean, that'll come up. Maybe that's not what I was saying anyway, but yeah. Compilers don't read comments or design documents, and neither do many programmers. What is expressed in code has defined semantics and can, in principle, be checked by compilers and other tools. Yep. Because comments, you know, like, the more information that you can feed the compiler as well is quite useful for tooling. The first declaration of month is explicit about returning a month and about not modifying the state of the date object. The second version leaves the reader guessing and opens more possibilities for uncaught bugs. Right. I mean, probably should they call it like get month, right? But I guess month is like an alias for int, quite useful, or an enum or something maybe. In fact, it probably isn't enum in this case. That would make sense to me. And then const, yeah, you know what I mean? Like, yeah, just like add. Especially for C++, where these things aren't enabled by default, like things are not const by default, for instance, unlike, say, Rust. Definitely adding those where you can is extremely important. This loop is a restricted form of standard find, so here's a bad example. If a vector string, bad, plus should use GSL : index. Int index equals -1. Why? GSL index. It's a vector of strings, right? Why not just do like size tier then? I don't understand. What is GSL? I actually don't understand what GSL is. C++ GSL. Guideline support library. Functions and types that are suggested for use by the C++ core guidelines. Okay. And this is Microsoft's implementation. Are these available anywhere? Here's span. GSL span enforces bounds checking. Interesting. So it's like different versions of the standard library. That is very interesting indeed. Okay. I wonder what's special about GSL index. A much clearer expression of intent would be auto p equals find. Yeah, I mean, what the hell? So basically condensing all of this into just a range, which is, I guess here, standard ranges find, I assume. Or just standard find even. Yeah. Yeah. And like, I literally used this in my tic-tac-toe game earlier, well, I guess yesterday now. When I was, using ranges just to condense things. I don't know. A well-designed library expresses intent, what is to be done, rather than just how something is being done. Far better than direct use of language features. Yeah, like declarative code, you know. But declarative code doesn't have to be like not imperative. It's just that it can be imperative or procedural, just under the hood, and then wrapping it in a function helps make it appear more declarative if you want to like quickly skim it. A C++ programmer should know the basics of the SDL or SDD and use it where appropriate. Any programmer should know the basics of the foundation libraries of the project being worked on, use them appropriately. These are still philosophies, right? Any programmer using these guidelines should know the guideline support library and use it appropriately. Shit, I also know the guideline support library. Take me to it. Here we go. Are they actually implemented? Oh yeah, like it actually exists. I do wonder how that will work. Okay. I'm really lacking, by the way. I think it's because this document is just huge. Although I should have like optimal web page viewing or whatever. Example, change speed, double S. What does S signify? Change speed 2.3. A better approach is to be explicit about the meaning of the double, new speed or delta on old speed, and the unit used. Interesting. So change speed, speed S. I mean, or just do double speed is fine as well. I think. I don't think this is necessary. Like, you can do this, but you probably want another reason to give it an alias, or like more than just an alias. 2.3, no unit, 23 meters per 10 seconds. Interesting indeed. This is valid, right? Because you can do literals like this. Oh, that's a bit jarring. That's underscored M, that's S. But yeah, interesting. We could have accepted a plain unitless double as a delta, but that would have been error prone. If we wanted both absolute speed and deltas, we would have to find a delta type. Okay. Enforcement, very hard in general, yep. Use calls consistently, check every function with the functions. Flag use of casts, yep. Detect code that mimics the standard library. Okay. P2, write an ISO standard. Yeah. So there are environments where extensions are necessary to access system resources. Right, so like compiler extensions basically. So yeah, it is a shame that a lot of these extensions aren't standard. Using valid ISO C++ does not guarantee portability. Avoid dependence on undefined behavior, of course, and be aware of constructs with implementation defined meaning. Size of int. Okay, I understand. There are environments where restrictions on use of standard C++ language or library features are necessary, like to avoid dynamic element allocation, as required by aircraft control software standards. I see. In such cases, control their disuse with an extension of these coding guidelines. So the enforcement is use an up-to-date C++ compiler with a set of options that do not accept extensions. Like what though? Like is no discard an extension? I don't know. I'm gonna assume I don't use any because they come like built in with Clang and stuff, so I assume that's fine. Express intent, unless intent of some code is stated, it is impossible to tell whether the code does what it is supposed to do. And even if there are comments, those can be outdated. Names are the most important, are the best thing. What is GSL index? Like what actually is it? Is it just a size T under the hood? It's an alias for a signed integer type like pointer diff t. Recommended for container indexing and loop iteration. Interesting. Okay. Yeah, cause like I use high C for everything. So having like an index type would be quite handy, wouldn't it? Take my socks off because my skin is hella dry right now and my socks are not helping. While I less than v dot size, do something with v. The intent of just looping over the elements of v is not expressed here. The implementation detail of an index is exposed, so it might be misused. Yeah, so you want to use a range-based loop, right? Yeah, like this. So here's const auto, so we know we're not going to modify x within v, and everyone's chill. Now there's no explicit mention of the iteration mechanism, and the loop operates on a reference to a const element so that accidental modification cannot happen. And if you want to, then you just remove the const. Pretty straightforward. For more details about for statements, see this. Okay. Sometimes better still, use a named algorithm. This example uses the for each from the ranges TS. What's TS again? Because it directly expresses the intent. Yeah, fair enough. For each V. Well, actually, I would disagree. I feel like this is just overkill. Because, like, this is literally just for each. For each X and V, do this. For each from V, an X lambda. These literally should read the same. Except this one is just harder to read because it's a function. Oh, phone call. Hello? Yeah. Well, yeah, good, because I want to go to sleep, and I can't sleep until you come. Alright. Bye. My brother's coming home. I'll be free. The last variant makes it clear that we are not interested in the order in which the elements of V are handled. Par. What does that mean? But that's interesting. A programmer should be familiar with these and these, whatever foundation libraries are useful for the current projects. Okay. Alternative formulation. So yeah, I'll look into this guideline support library. I've literally never heard of it until now. I assume this one is just this standard library, like the normal one. Alternative formulation. Say what should be done rather than just how it should be done. Say what should be done rather than just how it should be done. Yeah. Which is, declarative, but like it's not saying you just say that. Say both and wrap that in declarative code. Some language constructs express intent better than others. It's true. That comes down to the language design really. If two ints are meant to be the coordinates of a 2D point, say so. Draw line int. Draw line point. Clear. Yes, this I agree with. Group them together, right? Like this is xy height width, this is x1 y1, x2 y2. It's just a nightmare. Enforcement. Look for common patterns for which there are better alternatives. Or give names, by the way, but that's where named function arguments come in handy. But this is for C++, not for other languages. So it makes do with what it has as well. Look for common patterns for which there are better alternatives. So simple for loops versus range-based for loops. These interfaces versus span interfaces. Loop variables in too large a scope. Naked new and delete. Functions with many parameters and built-in types. There's a huge scope for cleverness and semi-automated program transformation. Right. Yeah, okay. Just to kind of address these, I do use range-based for loops where it makes sense, but if I want index access, then I will do that, of course. Order doesn't matter as well. Yeah, span. I tell you span. I think span's great. Fat pointers. Loop variables in too large a scope. Don't really know what that means, to be honest. Naked new and delete. Avoid that if you can. Functions with many parameters and built-in types. Here you would probably wrap them into a struct instead. So you don't have like a huge function list, parameter list. Ideally, a program should be statically type safe. Also, if you have like loads of function parameters, I believe that can be a problem for like registers and stuff, and like the performance wise. Maybe the compiler optimizes it. I don't know. Ideally, a program would be completely statically compile type safe. Unfortunately, that's not possible. Problem areas: unions are not type safe. Don't I know it? Casts, array decay, yep, range errors, and narrow conversions. Tragic. Yeah. Narrow conversions you can be warned on, thankfully, through static analysis. And even compilers can warn you. Compilers can obviously do static analysis too. Yeah, unions are a real pain in the ass. because I've tried implementing tagged unions, and having those be type safe is just not really a thing, it seems. At least not yet. But I think pattern matching might help with that, because that can be exhaustive. These areas are sources of serious problems, crashes, and security violations. Yeah. We can ban, restrain, or detect the individual problem category separately, as required and feasible for individual programs. Yeah. So unions, use variant. I use variant for my errors. I didn't realize that you shouldn't use unions in general, and that variant was like an actual alternative. I thought variant was just like a special use case. I didn't realize it was literally meant to be like a genuine replacement for you for the core union feature. So that's quite interesting. But yeah, I'm happy to use variants over unions. Cast, minimize their use. Templates can help. Casting. Yeah, I don't do much casting unless like I need to like do something hacky. Usually, if you need casting, it's more of either a design flaw, because you are for some reason designing things to not have compatible types, or you are doing interop with a library that isn't yours, and therefore you have incompatible types that way. But generally speaking, you probably shouldn't have that many casts anyway. Or like if you're interpreting data as well, which is another thing. Like if like in my binary modding stuff, but anyway, that's quite low level stuff anyway. Array decay, use span. Yep. Range errors, use span. Span is great, chat. Specifically from the GSL, I do wonder how the GSL span differs. I am curious to see how that works. Narrowing conversions, minimize your use and use narrow and narrow cast from the GSL. I see. Okay. Prefer compile time checking to runtime checking, of course. And it's just easy as well, and you don't have to write error handlers. It's just easier in every single way. Int is an alias used for integers. Don't avoidable code. Int bit equals 0. Int I equals 1. I is bit shift to left bit shift equal into 1 plus bits. What the hell? If base less than 32, int too small. Instead, use a static assert. Okay. Yeah, I mean, bit shifting stuff just kind of flies over my head a bit. I mean, it's an int, right? It's probably U32. So it's shifting it. What's the condition here? Until it's 0. Oh, it's just like a bit counter. It just counts the bits. I see. Okay, cool. I'm surprised I was able to actually read that. Or replace int with int32t. Yes. It pisses me off so much that these are like not more accessible. Like I have to write standard : int32 underscore t. Like just give us i32, bro. And like the fact that like standard float still isn't in the fucking library. Like it is for GCC, but like for Clang it doesn't work. Like the standard float header just isn't implemented properly, even on like Linux. So it's really annoying. In the big 2026. Again, I understand why, but I'm just saying it is annoying. Regardless, void read. Yeah, don't use row pointers. Use spans. Letting a pilot figure out the number of elements. Yeah, exactly. Alternative formulation. Don't pass pointer runtime. What can be done without compile time? Look for pointer arguments. Look for runtime checks for range violations. Yeah, I really don't use pointers like ever at this stage. What like I mean like in arguments. What unless I need to use it for optional, but that's gonna be fixed soon. What can be checked at compile time should be checkable at runtime. Yep. Ideally you catch all errors and not errors yet. And it can be quite tedious to do this, but very important. Now in my case I actually do catch all the errors, but my error catching system isn't very useful because it doesn't like catch good metadata. Really that's where a debugger would come in. It is impossible to catch all errors in compile time and often not affordable to catch all remaining errors at runtime. Separately compiled, possibly dynamically loaded. Okay. Here, a crucial bit of information has been so thoroughly obscured that static analysis is probably rendered infeasible. And dynamic checking can be very difficult when f is part of an ABI, so we cannot instrument that pointer. Yeah, it's why I really struggle to use Rust well, because of how Rust has like great static analysis, but the moment you want to like do something modding wise, like do some kind of modding thing that requires you to like interact either with a library or with like a game's memory directly, like you're fucked. Like everything just becomes unsafe, and quite frankly, unsafe Rust is not very fun to write. So maybe Zig I'd have more success with. We could embed helpful information to the free store, but that requires global changes to a system and maybe to the compiler. So a bad example. The wrong number of elements can be passed to F2. Okay? Is there a good example? Passing the number of elements as an argument is better. But then just passing... Okay, but... However, a simple typing is just serious. Okay. F2 is supposed to be to delete this argument, or did the caller make a second mistake? Huh? Another bad example. Bad, pass ownership and size separately. Okay. So just what? Just use a span. Okay. I thought the point here was that you couldn't, but I guess you can. We just pass point to the number of elements as an integral object. Right. Yeah. So this assumes that the calling code is ABI compatible, using a compatible C++ compiler and the same standard lib implementation. I mean, same with Rust. If you're not using a compatible Rust compiler, then you can't use a fat pointer. You just can't. And it kind of annoys me that we're in 2026, and I'm gonna say the big 26 a lot because like this is the big 26, dude, and we still don't have like consistent ABIs agreed upon in the computer science world, programming world, for like fat pointers, dynamic arrays, strings. Like, I get that different languages have different implementations, but surely there's like some things we can agree on, like just to like help things a little bit, to be a bit safer, like have a safe pointer, be standard, you know, because like we still use C ABI, but C is like inherently just unsafe and not great for static analysis, and it's easy to make mistakes. So why do we still use C ABI? Like why do we have like an expanded one, you know? Like surely there are only so many good ways to implement a span or a fat pointer or a slice or whatever. But maybe I'm mistaken. So what's NB, by the way? I see a lot, but what does NB stand for? Note. Nota bene. Note well. Okay. Yeah, so it's annoying. I find it bizarre that we as in the computer science community still are yet to agree on a standard ABI for safe types like spans, slices, fat pointers. Surely there are only so many ways to implement things like these well, and we can move away from only relying on the C ABI. How do you protect both ownership and all information needed for validating use? Okay, move. Bad, loses N. Huh? What's going on? Okay, because this is a value, this is a pointer, and this is also a pointer. I guess, I don't know. Show how possible, but what the hell is this? Show how possible checks are avoided by interfaces that pass polymorphic base classes around. Okay. Enforcement. Flag pointer counts to interfaces. Okay. Catch runtime errors early. Avoid mysterious crashes. Avoid errors leading to wrong results. So this is error prone. Here we made a small error in use 1 that will lead to corrupted data or crash. Okay, so an improvement would be doing this. First of all, a range-based loop. Okay. A span. Okay. Oh yeah, this constructs. I do forget that you can implicitly construct the object like this without having to like type out standard span everything. I never do this though, for whatever reason. I probably could sometimes. It's not a huge difference deal though. The number of elements of a need not be repeated. I see that's a typo there. Oh yeah, by the way, are there more branches for this? Perhaps. Don't repeatedly check the same value. Don't pass structured data as strings. Read dates from iStream. Extract date from string. Don't pass structured data as strings. The data is validated twice by the date constructor and passed as a character string and structured data. Okay. Access checking can be costly. There are cases where checking early is inefficient because you might never need the value or might only need part of the value that is more easily checked than the whole. True. Similarly, don't add validity checks that change the asymptotic behavior of your interface. Don't add an ON check to an interface with an average complexity of 01. Hell yeah, obviously. Otherwise, you'll just slow things down. Float x, y, z, e. Should I check here that the values are physically meaningful? So this is what physics says. That e times e is less than x times x plus y times y plus z times z. The physical law for a jet is not invariant because of the possibility for measurement errors. Okay, philosophy 8, delicate resources. Even a slow growth in resources will over time exhaust the valuability of these resources. Yeah, people usually talk about like memory leaks as like a security issue, and while it definitely can be, it's also just slow. it's just bad practice as well, because it can lead to crappy software slowing down, crashing, whatever. Void f file input f open name. Holy C. Yeah, here we're using an IF stream. Refar RAII. Safer. Or you know, if it was Zig, you'd use defer. But I think RAII is quite nice. A leak is colloquially anything that isn't cleaned up. The more important classification is anything that can no longer be cleaned up. For example, allocating an object. On the heap, and then losing the last pointer, that pointer allocation. This rule should not be taken as requiring that allocations with okay. Yeah. Yeah, like if your program shuts down, then it gets cleaned up anyway. So sometimes you can get away with that, but yeah, better safe than sorry. And like if your user is already shutting down your program, they probably don't care about it taking like an extra few seconds if it means that it's calling destructors. But maybe I'm wrong. Plus, I feel like the compiler could probably optimize that anyway. Well, I really have not made a dent in this. Look at how like far I've scrolled down so far. Enforcing the lifetime safety profile eliminates leaks. When combined with resource safety provided by RAII, it eliminates the need for garbage collection. Because there's no garbage, exactly. I don't like garbage collection. Combine with this with enforcement of the type and bounds profiles, and you get complete type and resource safety guaranteed by tools. Profiles. Look at pointers. Classify them into non-owners and the owners. Where feasible, replace owners with library resource handlers. Like what? Like unique pointer? Oh no, like this, like ifstream, of course. I've lost it. Actually, I don't actually know how ifstream works under the hood, by the way. I do wonder. Alternatively, market owner as such using owner from the GSL. Look for naked, new and delete. Look for known resource, yeah. Okay, don't waste time or space. This is C++. Time and space that you spend while to achieve your goal is not wasted. Another benefit of striving for efficiency is that the process forces you to understand the problem in more depth. Alex Sipanov said this. Okay. Char int string char. I'm assuming that's like not laid out great. What the hell is this? This is a caricature. Jesus Christ. We have seen every individual mistake in production code and worse. Note that the layout of X guarantees that at least 6 bytes are wasted. Yeah, I mean, Andrew Kelly has done many talks about this, and data-oriented design. Very interesting, of course. It would be nice if the compilers just optimized it for us, but sometimes you do want things that also have a predictable ABI. The spurious definition of copy operations disables new semantics so that the return operation is slow. Yeah, honestly, when I write classes, I really do not optimize for space whatsoever. I probably should. The use of new and delete, but again, like, compilers should do this automatically. I believe the Rust compiler will actually sort it automatically for you. Unless you tell it not to, because like you want it to be like C decal or something, whatever. But like otherwise, it will actually maintain it, which is sorry, not maintain it. It will change it to be optimal, which I think is cool. The spurious definition of copy operations disables new semantics. Okay. Bad example. Lower Z string. How's the Z string? I less than string length s plus I si equals to lower si. This is actually an example from production code. This expression will be evaluated in every iteration of the loop. This means that string length must walk through a string every loop to discover its length. Right, so you just like basically store it as a variable instead. Which, to be fair, compilers also should optimize sometimes, I think. While the string contents are changing, is assumed. Oh, right, because it's changing too. It's better to cache length outside the loop and not incur the cost each iteration. Yeah, like what? One example is like whatever, but you know, if you have it as a habit, you're gonna have these things everywhere, which will eventually add up to big problems. The aim of this rule is to eliminate the most waste related to the use of C++ before it happens. Okay. Flag an unused return value from user-defined, non-deforested. Okay. Prefer using the prefix form instead. Prefer using the prefix form. I use the suffix form only. Perhaps I should change my ways. Many more specific rules in with the... Okay. Prefer immutable data to immutable data. Like in Rust, right? It's easier to reason about constants than about variables. Something immutable cannot change unexpectedly. Sometimes immutability enables better optimization. You can't have a data race on a constant. Yeah, very interesting, honestly, immutability. There's a whole argument for it, which is why Rust has it by default, and also why even, even with it supporting immutability, it still prefers you to use const when you can. Obviously, functional programming like Haskell and whatnot, I will also highly prefer you use constants where you can. So it is interesting. Encapsulate memory constructs rather than spreading through the code. Messy code is more likely to hide bugs and be harder to write. A good interface is easier and safer to use. Messy low code breeds more such code. Right, so encapsulate those.
Am I heading the right direction?
Where are you?
Local Express.
I genuinely don't know where you are.
Serious?
Show me your surroundings. Are you following Google Maps?
No.
Are you following any map?
No.
Well, follow Google Maps then.
Is it down that road?
I can't tell, Finn.
I don't know. Can I cross?
Just search for my accommodation.
What's that called?
St. Andrew's Gardens. Right. Bruh. My brother's on his way back, slowly but surely. Messy code is more likely to hide bugs. I just read that right. Int size equals 100. Int pointer p equals cast malloc size of int times size. Int equals 0. Well, this is so C style. But C programmers will swear by this and say C++ sucks, man. I want to be able to write code like this, and then drool over Odin and stuff. Obviously I'm exaggerating, but this is just, I hate this so much, dude. If you unironically like this, I feel like you are a problem in software engineering worlds, and you should keep this to your own personal projects. This is low-level, verbose, and error-prone. For example, we forgot to test for memory exhaustion and assign new value to size. Instead, we could use vector. Vector int v, vlet reserve. Wait, is that what it's doing? Surely this is not the same code, right? So they're kind of like a dynamic array. Is that what's happening? Because it's malloc, right? And yeah, and then we have realloc. That's insane. Well, now I know how dynamic array works. I did not know that realloc was a function. I'm gonna be completely honest. I thought that it would work differently. Like you have to delete it and then move it or something. But that makes sense, I guess. I mean, there's still a question of what's going on under the hood here, but still. There's no way. Where is cin coming from? Where's an int into x? I guess it's just too complicated to put there right now. For int x, cin into x. Right, so as long as there's more things to put in, push back. Interesting. The Center library and the GSL are examples of this philosophy. For example, instead of messing with the arrays, unions, blah blah blah, that are needed to implement these sessions, we use the libraries designed and implemented by people with more time and expertise than we usually have. Similarly, we can and should design and implement more specialized libraries, rather than leaving the users with the challenge of repeatedly getting low-level code well. What's this subset of superset? Look for messy code, such as complex pointer manipulation and casting aside the message. Okay. Use supporting tools. Yeah, computers don't get tired, so we should, take advantage of the fact. Stack Analyzer, I use Clang, but there are other things, of course, that you can also use. In particular, bro, I seen a debugger, on God, bro. C++, we got Clang. CPP lint GCC has its own thing built in. I mean, to be fair, I think Clang and GCC are fine as they are for stack analysis. Like those are built in. Okay, I gotta go. Use support libraries as appropriate. You downstairs? I'll be right there. Okay, let's wrap this up. Use support libraries as appropriate. Using a well-designed, well-documented, and well-supported library saves time and effort. Its quality and documentation are likely to be greater than what you could do if the majority of your time must be spent on implementation. Yeah. Yeah, like use people's libraries, you know, to save time. And while these libraries are more likely to be up to date, is true. Knowledge of widely used library, yeah. Examples and sort, okay. Yeah, and that includes the center library as well. I've heard this argument before, like rather than trying to like implement your own vector in the praised chance of it being more efficient, just uses the center libraries one. So by default, use the ISO one, of course, and so the guideline support library. Again, I'll come back to that. If no well-designed, well-documented, and well-supported library exists for important domain, okay. So that's pretty simple stuff. This is where it gets quite interesting. So I'm gonna go to bed soon, but I'm gonna continue reading that later. I, as you can see, I still have like barely dented it. It goes on way longer, like way longer. But I will come back to that and keep reading it, and yeah, see what I can learn from it. So far, pretty non-controversial things there. Although I think there are some things that are a bit more controversial, so I do look forward to getting to those as well, so I can get my opinion on them. But yeah, that is it for now. Subscribe to see more CBP guidelines. Also, I said I'd read those before the CB Plus documentary, but seeing now how long it is, the guidelines are, I'll probably just watch the documentary like sometime soon anyway. So yeah, subscribe to see that as well. There you go.